Hi! For this lesson, you're going to need the refraction of light notes. Let's go! Looking through the stained glass window, isn't this beautiful? How light separates into the different bands in the electromagnetic spectrum. Why does it separate like that? Something causes it to go from white light to all the different bands. And it's the topic of today's lesson. In reviewing of light waves, we know the difference between light waves and mechanical waves is that light waves, or electromagnetic waves, don't need a media to travel through. For example, I can see faraway stars with the light traveling all the way to Earth in empty space. They don't need particles to vibrate, and yet they can travel through media. Example, they traveled through the atmosphere and the air to reach you, didn't it? But it's not traveling in the same way like in sound waves, vibrating particles back and forth. Electromagnetic waves are special in that way. Pencil in the water trick. Time to pause the video and watch how a pencil in the water may look bent. Or if you're in class, try it there. What happened to light waves at the interface between different media? In other words, what happened to make the pencil look bent? Well, think about it. The light traveled through the air, then it hit the interface of water and air, traveled through the water, and then left the water through the glass. And every time it did that and left one media to the next, the light bent. And because the light bent, the pencil looked bent. We can measure this. Let's talk about the refraction test in our guided notes. If you're in class, you will perform the refraction test in person. If you're not, pause this video and go to the refraction test virtual lab. Then come on back here. In review of the lab in the setup 1, the incoming laser beam bent or refracted as it went into the dish of water. And in the same way, going from water to air, it bent, this time forward. I want you to experiment with refraction. You can go to the online simulation in fosweb.com, click the Waves module, click the word refraction, and change the media in which light has to travel through. This type of concept, it has real world application. The archerfish uses refraction to capture its food. Pause the video and watch the archerfish hunt. People also use refraction to spear hunt. Pause the video and watch archer fishing and spear fishing in real life application. After watching those videos, what are the takeaways? The blank, the angle of incidence. The blank, the difference between angle of incidence and refraction. I'll give you a hint. You'll be using the words greater and or increase or lesser, those types of words. In setup 2, same thing, but in the very last blank, we have a word called total internal reflection. When the light is refracted so much or entering the interface so much at an angle, it can't escape anymore. You'll notice in the experiment that that angle was around 50 degrees. The light no longer escaped. That's called total internal reflection, an important concept for the next unit. So why does light scatter like this? When it goes from one interface to the next, it bends. And if you go from something less dense like air to something more dense like glass and water, the greater the bend. If the light is slowing down a bit, it will bend and cause it more difficult time to fish, or just cause a very beautiful stained glass reflection upon my face. It is now time to read seismic waves and talking about refraction through solid crustal material. Answer the questions in your guided notes to finish up this lesson. Thanks for listening.